Nyco Canada Inc. received an invoice on March 17, 2021, amounting to $45,000 with terms 510, 320, net 30. Nyco Canada Inc. made the following payments: $10,000 on March 27 and $15,000 on April 6, and the balance on April 12. What was the total paid for the invoice? To solve this problem, we first note that March 17, 2021, which is the invoice date, is day 0. Invoice date is always considered to be day 0. Another important date here is March 27, when the first partial payment of $10,000 was made, and March 27 appears to be day 10, starting from the invoice date, which is day 0. Next important day is April 6, and this date is day 20. Because March 27 partial payment was made on day 10, we fall into this first discount window, and the first payment is subject to 5% deal. This means that credit X1 will be given for the first partial payment. How big is this credit? Well, X1 should be such amount that if discounted by 5%, because it's 5% discount during the first 10 days, should be equaling to the first partial payment, which is $10,000. From here, we will be finding X1, which is the first credit received, which is $10,526.32. This means that by paying $10,000, the company now has paid out $10,526.32 of the invoice. Let's find the balance after the first partial payment. We'll call this balance B1. The total on the invoice is $45,000. We'll subtract from this total the credit received. This is equal to $34,473.68. After this, the second payment of $15,000 was made on April 6. Because April 6 is day 20, the second partial payment falls into the second discount window, which is 3% discount. We'll find now the second credit received, and that second credit received is of the size that, if discounted by 3%, should result in that second payment, which is $15,000. From here, we'll find X2. $15,463.92. After this second payment, we can find the second balance. This second balance will be the balance after the first payment, which is $34,473.68, minus the credit received after the second payment, $15,463.92, $19,009.76. This balance is what the company has to pay at the end to completely pay off the invoice. Now we can find the total amount paid for this invoice. This total amount consists of the first partial payment, which is $10,000, the second partial payment, $15,000, and also the balance that the company has to pay, $19,009.76. This is equal to $44,009.76. This is the answer to this problem. The company paid $44,009.76 for this invoice of $45,000 by making two partial payments specified in this problem. Note that this problem could be solved easier. We found x1, then we found x2. What we could have done, we could add x1 and x2. We would find total credits received. Using those total credits, we could subtract them from the amount of the invoice, which is $45,000. We would get the balance right away. And then we could find the total. However, this solution also shows how to find balances after each iteration so that it's more clear what's going on when the company pays those partial payments. For an invoice of $50,000 with terms 715 net 30, what payment made during the discount period will make the balance equal to $20,000? In this case, we do not know the partial payment. So the partial payment is something we don't know. But we know that for this partial payment, there will be a credit received. And the size of this credit is such that if discounted by 7%, it is 7% discount because it's specified in the terms. We should be obtaining that partial payment. From here, we can find this credit, which is P divided by 0.93. Once we find this credit, we can now build this equation. $50,000, which is the total on the invoice, minus the credit, which in this case is P over 0.93. If we take the total on the invoice and subtract the credit received, we should be obtaining the balance, which is given here, $20,000. Now we need to solve this equation. I can rewrite it in the following form. P over 0.93 equals to $30,000, which is 50,000 minus $20,000. P is equal to $30,000 times 0.93. The answer is $27,900. Thus, if the partial payment is $27,900, the balance after that partial payment will become $20,000. After returning from his trip to USA, Jason sold his remaining 2,100 United States dollars to a bank in Toronto. This bank quoted exchange rate of United States $1 equals to Canadian $1.3854 with 1.5% commission to buy or sell currency. How many Canadian dollars will Jason receive? What we need first to note here is that the bank is in Toronto, which makes Canadian dollars a local currency. Therefore, we see that this part of the exchange rate is the domestic part of the exchange rate, and also this defines the bank's buy rate. The thing is that Jason sold his US dollars to a bank in Toronto. However, because United States dollars are a product in Canada, it is not domestic currency in Canada, therefore it's a product in Canada, and we always consider buy or sell rate from the position of a bank. In this case, the bank bought US $2,100 from Jason. So therefore, we're talking here about buy rate. Once again, buy rate is because the bank is in Toronto and that bank buys foreign currency. We always define buy or sell rate from the position of the bank in terms of the foreign currency. So this is the buy rate. How do we find the buy rate? Buy rate is based on the exchange rate. We have to subtract commission from the domestic side of the exchange rate. The domestic side is this one here, Canadian dollars 1.3854. So the buy rate is US $1 equals to Canadian 1.3854 with commission subtracted, and the commission is 1.5%. After we find this buy rate, we can build a ratio which will help us to find the amount in CAD Jason will receive. So this ratio is built in the following way. 1 USD is to 1.3854, 1 minus 0.015 Canadian dollars. This is the same as 2100 USD that the Jason brought to the bank to unknown number of Canadian dollars. Now we'll be resolving this ratio. So X is equal to 2100 times 1.3854, 1 minus 0.015. If we compute it, we'll find 2865.70, rounded to 2 decimals. So Jason will receive $2,865.70 in exchange for his $2,100 USD. In this problem, there are two parts. Part A. What is the markup rate on selling price if the markup rate on cost is 23%? Part B. Using the previous answer, determine the break-even price if the required profit is 10% of cost and the selling price is $57. So in part B, we need to use the answer from part A, which is the markup rate on selling price. We will be using markup rate on selling price in order to solve part B. But let's first address part A. We will notice that markup amount is 23% of cost, so 0.23 times C. Selling price is cost plus markup, which in this case is 0.23 C, which makes selling price 1.23 C. We simply would factor out C, and once we factor out C, we will see that it's going to be 1 plus 0.23 in the brackets. Thus, we can see here that it's 1.23 times C. Markup rate on selling price, we'll call it RS, is equal to markup divided by selling price. So it's going to be 0.23 C divided by 1.23 C. C will be cancelled because C divided by C is 1. We're left with 0.23 divided by 1.23. If we compute it, we obtain 18.70% rounded to 2 decimals. This is the markup rate on selling price, which we now need to use to find the answer for B. Let's address part B of the problem. In part B, we need to find the break-even price. Break-even price is cost plus expense. In order to find break-even price, we first need to find cost. To find cost, we'll remember that selling price is cost plus markup. Selling price is given as 57, cost is unknown, and markup is 18.7% of the selling price, which is 57. From here, we'll find cost. 57 minus 0.187 times 57. Cost is equal to $46.34. After we found the cost, we now can find expense, because that's another thing we're still lacking to find break-even price. Expense is markup minus profit. Expense is markup, which is 0.187 times 57, minus profit, which is 10% of cost, which we already found, 46.34. From here, we'll compute expense, 6.03, so $6.03. Now we have everything ready to compute break-even price. Break-even price is cost plus expense. We found the cost and we found expense. Now we need to add cost and expense. That will be the break-even price. 46.34 plus 6.03. Break-even price is $52.37. And that is the answer for this problem. Find monthly break-even revenue for a calculator that sells for $45 and having variable cost $32. It is known that annual fixed costs for the business that sells calculators amount to $15,000. It is important to note that we're given annual fixed costs. However, the question is about monthly break-even revenue. We need to identify first monthly fixed costs. To do this, we'll take annual fixed costs, $15,000, divide that by 12. This will give us monthly fixed costs, which are $1,250. With this, we are ready to find N, which is the number of items or the number of calculators to break even. This number N is equal to fixed costs divided by contribution margin. I will remind that contribution margin is selling price minus variable cost. Contribution margin is the amount that we contribute towards paying off the fixed costs and potentially towards making some net income. In this case, this formula should be clear. So we take all the fixed costs and we find how many times contribution margin fits into the fixed costs, which will give us the number to break even. This is equal to fixed costs per month, which is 1,250, divided by contribution margin, which is found as 45 minus 32, because $45 is the selling price and $32 is the variable cost. If we compute it, we'll find that N is equal to 96.15 rounded to 2 decimals. When we found number N, it is the number of calculators to sell per month to break even. Because we cannot sell 96.15 calculators, we need to round this number to the next whole number. So this becomes 97 calculators to break even. After we find this number, we are ready to find break-even revenue. Break-even revenue is the break-even number N times S, which is the selling price. So it's 97 times 45. This is equal to $4,365. That will be the answer for this problem. I just want to note that it's important to read the problem carefully because the problem is asking for break-even revenue, which means the dollar amount which needs to be sold in order to break even. When you find this number N, which is the break-even number, that's not revenue. That's just a break-even number of calculators. This number N is also called break-even volume. By the way, note that we rounded this number to the next whole number, and then we use that rounded number to compute the break-even revenue. Assume that for your upcoming trip, you would like to buy $5,000 USD. How many Canadian dollars will you have to pay for this to a bank in Montreal if the exchange rate is 1 Canadian dollar equals to 0.6812 US dollars? The bank charges 2% commission to buy or sell currency. Again, in this problem we note that the bank is Montreal, which makes Canadian dollar a local currency. So this is now the domestic side of the exchange rate. We also note that you would like to buy 5,000 USD. However, in order for you to buy USD, the bank needs to sell USD to you. We always consider the position of the bank when we define buy or sell rate, because the bank in this case will sell USD, will sell foreign currency, that is going to be sell rate. In order to find the sell rate, we need to add commission to the domestic side of the exchange rate. In this case, the sell rate will become Canadian $1, which is increased by 2% commission. This is equal to US dollar 0.6812. With this sell rate, we'll now build the following relationship. 1.02 Canadian dollars is to 0.6812 USD. That should be the same as a known number of Canadian dollars to 5,000 USD. From this, we'll find X. It is 5,000 times 1.02 divided by 0.6812. This is equal to 7,486.79. We found the answer, which is 7,486.79 Canadian dollars, which will be given in exchange of 5,000 US dollars that you would like to exchange with this bank. What sequence of discounts will result in a lower net price given the same list price? A, which is 20, 10, and 7%, or B, which is 18, 11, or 8%. Prove by finding the single equivalent discount rates for A and B. Well, first, for A, we need to find equivalent discount rate, which is 1 minus 0.2, 1 minus 0.1, 1 minus 0.07. This is equal to 0.3304. For B, single equivalent discount rate is 1 minus 0.18, 1 minus 0.11, 1 minus 0.08. This is equal to 0.328584. The question is, given the same list price, which discounts will result in a lower net price? So bigger discount will give the lower net price. In this case, the bigger discount is 0.3304, which makes A as the answer to this question. It is A sequence, which is 20%, 10%, and 7%, will result in the lower net price. What is the list price if a net price of $4,000 is obtained as a result of 3 trade discounts? The first discount is 11%, and each next discount is 2% lower than the previous. Well, we can build the following equation here. We don't know the list price, but we know that there were 3 discounts taking place. The first discount is 11%, so 1 minus 0.11. The second discount is 98% of the first discount, and the third discount is 98% of the previous discount. So notice how I wrote it 0.98 squared, because I basically have to multiply the previous discount by 0.98 again. This should be equal to $4,000 as the net price. Now, from here we need to find L. Let's compute this term first. If we compute this term, we'll obtain L times 0.710170,537. Of course, I keep it in the memory of my calculator, so I don't have to write it all every time. I just write it here for clarity. So L will be $4,000 divided by this term, which is 0.71 and so on, which is completely stored in the calculator memory, of course. That is equal to $5,632.45. Thus, the list price is $5,632.45, which after three mentioned discounts will give $4,000 as the net price. A store sells chairs for $120. The expenses are 12% on the cost and the profit is 18% on the cost. During a sale, the chairs were marked down by 20%. What is the profit or loss during the sale? Well, let's first find the cost of the chairs. In order to find the cost, we will build an equation. So selling price is cost plus expense plus profit. Selling price is $120 in this case because the store sells chairs for $120. That's a regular selling price. Cost is unknown. The expense is 12% on the cost, so 0.12 times C plus profit is 18% on cost, 0.18 times C. $120 is thus 1.3 C. So we factor out C. What we have is 1 plus 0.12 plus 0.18. It's 1.3. C from here is 120 divided by 1.3, which is 92.31. So $92.31 is the cost. Now we have sale. We need to find selling price reduced. And sale is marked down by 20%. So we take the selling price, which is $120, and mark it down by 20%. That is $96. So reduced selling price, that is the selling price during the sale, is $96. Finally, we need to find profit or loss made during the sale, which is called P reduced. That is found by taking the selling price reduced and subtracting break-even price. We already know the selling price reduced. What is the break-even price? Break-even price is cost, which we already found. It's $92.31. And plus expense. Expense we know is 12% on cost. So 0.12 times 92.31. This results in the break-even price, which is equal to $103.39 rounded to 2 decimals. So once again, reduced profit, which is given by this formula, is selling price reduced, which we already found, minus break-even price, which we also found. Therefore, we can find that P reduced is equal to minus $7.39. So this minus means it's a loss. Actually, there is a loss of $7.39 during the sale. What is the variable cost of an item? If it is known that in order to make the monthly net income of $5,000, the store must sell 2,300 items every month. It is also known that the selling price of each item is $30, and the fixed costs per month amount to $2,000. Well, in order to solve this problem, we'll remind ourselves that total revenue is equal to total cost plus net income. Total revenue in this case is the number of items sold, 2,300, times selling price of each item, which is $30. That's equal to 2,300 times variable cost. So this way we'll find total variable costs plus fixed cost, which is $2,000, plus net income, which is $5,000. I remind that this highlighted yellow is total variable costs, but this underlined red is total costs. So it's total costs, that part of the equation. and net income is $5,000. So this way, this equation should become clearer. If we now solve this equation, we'll find variable cost. So variable cost is 2,300 times 30 minus 7,000, so 2,000 plus 5,000 is 7,000, divided by 2,300. Thus, variable cost is equal to $26.96. This solves the problem.